Hello everybody, this is Eric Pistelli from Entico, and in this video we're going to talk about headers in Cerbero and how to use them. I'd like to thank the YouTube user GreyFox for giving me the idea for this and some other videos. So what are headers? Headers are basically SQLite databases which contain XML structures. These XML structures are a direct representation of C structures. So I'm pretty sure I'm going to forget something in this video because this is a very broad feature and I wrote it a lot of time ago. I wrote it back in July 2013. So you can still look up the blog because the blog contains very in-depth articles and I'm going to reference the blog throughout this video. But I hope I make this feature more accessible because it has a bit of a steep learning curve. So I'll try to simplify it as best as I can. Again, I'm pretty sure I'm going to forget something and bear with me if I don't remember all the things. So you can import these C++ structures in two ways, from C++ headers or using PDB files. We're going to see both methods and we're going to talk about the differences. In the blog you can, for instance, start out with a C++ types introduction. It shows you how to import these types from header files, from C++ header files. And these structures, we can use them both in the context of Python code, like programmatically, or we can use them in the context of a hex view for creating a layout and so on. So, well, let's start. The first tool, the most essential tool if you want to import these structures is the header manager. You can find it in the util section. And this is basically a tool which contains a whole Clang toolchain for importing C++ header files. It lets you specify all the parameters to parse the code, and in the editor you can basically define the structures and define the header names in which those structures will be imported. Let's make it very simple. We'll start with a very basic structure and then we'll see how to make it more complex. So if I press import and now I output the schemas, so it will show me the XML format of the structures which I'm going to import. This XML is a direct representation of this structure. If I wanted to put this structure in a file, in a header file, I could do it like this. At this point, I would have a SQLite database containing exactly that. Just to make it simple, you have this headers shortcut right here. So you just press that and you are taken to the headers. In this case, we have this simple structure database, which we just created, and it contains our structure. So I'll show you now how you can use this structure from a hex view. Let's open some file. Well, we can open even this file anyway. I mean, Cerbero directly. So we can now load a structure here in the context of the hex view. We just add structure. And at this point, we can choose the header and the structure. Now, you may have noticed that when I imported the structure, I didn't specify the packing or the endianness, nothing, just parsing parameters. This is because the structure itself just defines the fields. And when I apply the structure to data, I can actually define these parameters on the fly. I can define the endianness, the size of pointers, the packing, the compiler, and so on. The compiler is usually useful when we have, for instance, vtables and so on. I mean, again, this headers feature is very broad, and I went into insanity. I'll talk about this later, but there are many features in that to talk about. It supports vtables, inheritance, and so on. So, but let's not get ahead of ourselves. So we just specify that this data represents the A structure, and it will be shown in the hex editor. If we open the inspector, let's put it here, and we can see our structure and the data. We can even jump to it. If we're somewhere in the hex view, we can just jump back to it and see the representation of the data in the inspector. So this is a very useful feature to analyze files, and in fact on the blog you will have some examples dissecting files and importing structures. And one thing which is still to mention is, in this case I specified an extra file, but if I, for instance, am in the context of a file of a project, let's say, I just open the file, I can start a header manager from here. And when I start it from here, it's different because I can specify the this header. The this header is basically the header which will be associated to the project. It will be included in the project. So if I now import another structure from here, and we can see now we have our B structure. The difference is that the structure we imported before, which ended up in the headers directory, cannot be shared with someone we send our project to. In this case, it's different because the B structure is defined in the this header, and if we save our project and send it to someone else, he will have the same structures because they are defined inside the project. That's basically the difference. And one thing which is also useful to know is that, okay, this is basically the layout which I just created. I can rename it, and layouts will be saved in the project. And we can even export a header file. So we can do export or import, and we can save our header to disk and import it in some other project. You can basically, in this editor, you can define even includes. If I, for instance, specify header paths and I put the paths, the include paths here in the command line, I can, for instance, write code like include some header.h, and it will actually open the file, parse the structures, import them in the database. It's easier than pasting everything here, especially if you want to include multiple headers. You can just write one after the other, one include after the other, and it will parse all of them and put all the structures inside of the SQLite header database. And you can also define here in the preprocessor some defines. If you have some common defines like type defs or stuff like that, you can just put the code here and it will be saved for next sessions. You can even specify multiple header files to import into. If I, for instance, write A and then here B, and here I specify some other header like this. Now what will happen is that everything which is in some header will be included in the A header. Everything which is in some header 2 will be included in the B header. So I can define multiple headers from the same session. And I can even specify header end if I want to stop the importing into a specific header, write some other code here which or structures which I don't want to be imported, and then define another one. there are many possibilities. Sometimes you just want to, before a header, define some type defs just to make the parsing of the header possible, because it happens often that you want to include just the structures of a specific header file in C, and for that to happen you need specific defines or type defs, and you just define them before specifying the header start directive, and it will just ignore them, of course. And as I mentioned, there's another way to create a header file in Cerbero, and the second way is doing it from a PDB file. PDB files are used by debuggers for the structures and the types and the source lines. And if we open a PDB file, and PDB is a format supported by Cerbero in Cerbero, we can just run this action, dump types to header, and we just specify, in this case I did it already, we just specify the, let me do it again, we just specify the header file, and it will, yeah, and it just imported all the types. And again, if we open from the header manager the header which we just created, we can see all the types it imported, all the structures. And this is also one important difference between headers created from C++ or C header files versus headers created from PDB files. As you can see, when you create a header file, this is a structure which I imported from C, and as you can see, it doesn't define the size of the structure, and it doesn't define the position of each field. But in a structure imported from a PDB file, the structure has a defined size, and also the offsets are defined. This is a big difference, and in the future I would like also to give the option to already define sizes, and not sizes, but let's say how the structures are going to be mapped into memory, the packing and everything I showed you before. I would like to also give the possibility to the user to define it at import time, because computing structures on the fly is slower than doing it ahead. Although these structures, you can use them programmatically in the same way, underneath they behave differently, because again, one is defined as every field having a specific offset, and the other is computed on the fly. As I mentioned, there are some quite esoteric features in the C++ import of structures, and if you want to dig them, you are free to go on the blog and look up the post I wrote many years ago. It contains all the information about layouts, which I mentioned can be used also programmatically. You can create a layout from code, add it to a hex view. In fact, if you go back to the header snippet, from the code snippet action which was added in the last version. Wait, I have to be in the context of a text view. So now you can insert a Python snippet, and if you go on to UI, create layout, here you have it. This, for instance, is some Python code which creates a layout and creates an interval and sets the layout to a hex view. And the difference is, okay, in this specific example, it doesn't use a structure, it just uses an interval. You can define intervals as well, like this. So in this case, it doesn't use a structure, it just defines an interval, but you can, of course, define structures as well from Python and use them. Again, it shows you how to do this in Python using the SDK, and it also talks about header files. Header files, as I mentioned, are SQLite databases, but you can also specify them as XML strings. So you can create a header file load. There's a method called load from XML, and you can use that to just basically pass a string, and it will parse the header file rather than from a SQLite database directly from a Python string, for instance. So you can include header files directly in a Python string, Python script as a string. This is handy, especially if you don't have many structures. It doesn't make sense to use SQLite database. So as I mentioned, there are many features here. We saw pointers, endianness. You can have arrays, of course, of structures. You can define them programmatically, and you can define them, and you have substructures, of course. Here you can see a substructure, how it is defined. And you have unions, anonymous types, bit fields are supported, namespaces, inheritance is supported as a feature. vtables, so if you have, for instance, a structure with virtual functions, virtual methods, what happens is it will create a special vtable field, and depending on which type of compiler you specify when you want to parse a structure, like here. In this case, we could specify the compiler as VC++ or GCC or Clang, and it will correctly create a vtable the size of the compiler you specify. For instance, there is a difference between Visual C++ and GCC. GCC has larger, has 2 pointers for the vtables, for instance. So these are differences to be accounted for if you want to, for instance, parse something from memory, and you have a structure which has a vtable, so you have to actually take into account the differences here. So you have virtual inheritance. This is also something which is supported, and you have field alignment. This I specified already. So depending on if it's compiled for 64-bit or 32-bit, you have to specify the correct alignment, or if it's meant to be parsed from a file, you pack for 1 byte, so it doesn't have any alignment. Templates, this is a feature I've never used in my whole life. I just put it there because it was, I don't know, because I could, like typical nerd. No, just this is a funny feature because it allows you to basically, I mean, programmatically, you could do something like this. You can specify a B structure, which as a template takes a structure, which as a template takes an integer type, and it will resolve correctly because, again, these structures are computed on the fly, so it allows for this kind of, yeah, it's kind of crazy because probably nobody will ever use it. I never did, and if I didn't, probably never, no one will ever, but still, it's nice. You can also look up the blog for instance, this article shows, for instance, how to import structures for file systems. In basically 30 minutes I imported all the structures for all these file systems, created headers, you can even download them, and I created a small, I did some analysis on FAT32 disk, and I created a small utility in Cerbero to recover deleted files. It's all in the article. You can look it up if you're interested. This shows, for instance, how to create a layout programmatically and add structures for it, and then how to recover these deleted files, basically, all in basically 300 lines of Python code. So it's quite neat, and if you're interested, this may be a good, also more advanced introduction to the feature of headers. So what else did I want to talk about? I showed you PDBs, how to import structures from there. I showed you the hex view, and for instance, just to mention how I used this feature quite recently. Oh, one thing which is, for instance, useful to mention is that the PDB import is very useful for memory analysis. In fact, we import all PDB types for the system, for Windows system, for doing memory forensics. So all the types we have for memory forensics are imported from kernel symbols. So this is why we have this feature. And how I used, for instance, the headers recently, this is just, of course, one of the many ways you can use them, and when you reverse something, there's a million ways to do it, maybe do it better. I just did it like this because for me it was handy in that particular moment to do it. I was doing some CTF challenge which involved GNI code, and GNI, if you don't know, is the interface for Java to call C functions. And if you look at the typical Hello World implementation, you will have two arguments basically. Well, not two arguments, but the first argument will be the GNI environment. And if you look at the header file for GNI, the GNI is just pointer, defined as a pointer. And since this is already a pointer, it will be a pointer to a pointer. And if you have some disassembly in front of you, let me close some, which we don't need anymore. This we don't need. So if we have the disassembly in front of us, I know that this is the GNI pointer, and I know that this is basically taking the pointer to the pointer, moving it to array X, and then at this point it will take a specific function from there, because if you look at the GNI native interface, it's just a collection of pointers. Now, since these are all pointers, it's actually very easy. You could even make a script to parse the pointers, but since we have this header manager, which is quite convenient, I didn't bother to do that. What I did is just I took the whole basically a header file, and what I did is I started the header manager, and okay, I'll just specify GNI here, and oh, I had already specified it here, so this was not necessary. And oh, one thing which is need to mention is that, not need to mention, but need to have, is if you specify test mode, you won't import the actual structures, even if you define the header start. So you can just specify, well, check this checkbox, and when you do import, okay, this didn't import any structure because I have to specify C. And if I import again, now I have the structures. It tells me every structure is imported, but it didn't actually create the header file. You can use that just to debug, just to make sure you don't have any issues, warnings, errors in the parsing. Because, for instance, if I had some error here, it would tell me, just a compiler would do. So we can fix the errors and the warnings here before actually doing the actual import and creating the header file. So I remove now test mode. If I import now, it imported all these structures. At this point, I can use the GNI native interface to basically understand what is being called in the code. What I do here is basically I use a hex view just as a dummy. Let's create an analysis view, and let's add the GNI native structure, interface structure. So what I have to specify in this case, the packing as 8, the pointer size 64. Actually, the packing in this case is irrelevant because we have only pointers. So I can now open the layout inspector just to see what the fields represent. And if I go to the code and I have, for instance, again, this is moving the pointer, the first pointer, and this is moving to the second pointer in array X. I mean, it's doing the pointer in direction, and at this point I have to understand what this 30 means, and I can just look here. 30 is find class. Simple. So I can just command, okay, find class. And this again moves, we can, all these references to 1b8 are to the GNI environment pointer, which is again, it's a pointer to pointer. So this time it references 720. If we go to position 720, we'll see that it is an exception check. So I can just comment that and go on like that. Of course, I can make it simpler if I had many methods to comment. I just make a simple script parsing the XML, or I don't know, I can even extract this from the header file itself, and it's simpler, it's easier in this case than to parse C, or let's say complex structure in C, and the XML is fairly simple to parse, as you could see. So this is one way, of course, to use it, and we can, again, in this case, it would be possible to just extract the positions, the names, and we know that every 8 bytes there is a different function. But if it was a real, I mean, a more complex C structure with different types of different sizes, then you actually need to take into account the alignment in memory, and at that point it would make sense to actually use the CFF struct class in the Python SDK to just make it easy to compute all the positions for us, because at that point we just have to use the member offset. You just go to the CFF struct, because you basically can load a CFF struct from a header. You call make struct, you specify the header file, and you specify the name of the structure that you want to load. And once you have a CFF struct, you can just call member offset from the name or from the position. So you can just get a number of the member count. You can get the count of all the fields in structure and enumerate all the positions for each name, and it will, once you specify the offsets, the flags for the structure, how to compute it, if it's packed to 8, and if it has a certain pointer size and so on, it will calculate all the offsets for you. Of course, again, this is just one way to do this specific thing, which I did in this CDF challenge. There are many ways to do it. I know this tool very well, of course, and so I use this method, but there are other methods. It's just one way you can use C structure, so let's say the header manager, to perform a certain task. So I hope that this was somehow understandable introduction to headers. So I hope you enjoyed it, and till the next time.